Okay, so by request, I've been asked to do an ECG interpretation video. So this is an old infographic of mine that I created a couple years ago that breaks it down into 10 steps. The first step, which is cut off at the top, is to know your measurements. So in every EKG strip, first of all, there will be markings, little markings at the top of the strip, and in between two of those markings is a 3-second strip. So you want to go 1, 2, 3 markings, and that is going to constitute a 6-second strip. So that's how you know that you've got a 6-second strip. Also, you're going to look at those small little measurement boxes, okay, within the strip. So those tiny little boxes that you're going to see measure 0.04 seconds. And you'll have several of those boxes that constitute a bigger box up here, and that's going to constitute 0.20 seconds. So it is imperative that you know your measurements. Next, you're going to count the rate. So what you're going to do to count your rate is you're going to take your 6-second strip and you're going to count the R complexes and multiply that times 10. All right, so then you're going to note whether or not that rhythm is regular. So that's really easy. I used to, when I was first learning EKGs, I would take a blank sheet of paper and I would mark one R to R complex on my sheet of paper and I would march it out. And if every R to R complex marched out and was regular, then that strip was regular. Then you're going to look at the P wave that's before every QRX complex. Is there a P wave for every QRS complex? Is the P wave normal looking, or is it upright? And is it upright, and is there one that precedes every QRS? If something is off with the P wave, if it's upside down, if it's missing, if it falls after the QRS complex, then that rhythm cannot be called a sinus rhythm. Because if something is off with the P wave, if the P wave is not normal and upright and before every QRS complex, then that does not originate from the sinus node. Next, you're going to measure the PR interval. I often say that this should be called the PQ interval because that's what you're measuring. So to measure the PR interval, you're going to start from where the P wave begins to leave the isoelectric line, so where the P wave begins to go up, until the Q wave. So you're measuring from the beginning of the P wave to the beginning of the Q wave. Now, if this measurement is greater than 0.2 seconds, then you have a first degree AV block, okay? And so that's a PR interval that's too long. Next, you're gonna measure the QRS complex itself. So you're gonna measure the width of the QRS complex, and that needs to be less than 0.2 seconds long, or there's some kind of electrical block called a bundle branch block going on with the QRS. Next, we're going to look at the ST segment, or that segment between the S wave and the T wave that should technically be even with the isoelectric line. If that little segment falls below the isoelectric line, then there's some sort of ischemia going on. If that segment falls above the isoelectric line, or if there's ST elevation, then that represents infarction. Next, we're going to look at the T wave itself. It should be upright. If the T wave is inverted, then that's going to represent ischemia. Finally, we're going to measure the QT interval. So that's like the entire thing, from where the Q wave begins until the T wave ends. So that represents the entire cardiac cycle, as far as the ventricles are concerned. And so if that measurement is greater than, we say, 0.50 seconds, then this leaves our patient very, very vulnerable to dysrhythmias, because if some sort of electrical stimulation falls on that QT segment, like a PVC or something like that, that can send our patient into VFib or VTAC. So the longer that QT segment is, the more vulnerable our patient is, okay? So breaking it down again, first you need to know your measurements. 3 little markings on your strip represents a 6-second strip. To count the rate, you're gonna count your R's within that 6-second strip, multiply it times 10. That's gonna give you your rate. You also need to make sure that you know that a small little box represents 0.04 and a bigger box within the strip represents 0.20 seconds. These are all measurements of time, okay? You're gonna look at the regularity of the rhythm. In other words, you're going to look at every R to R and make sure they march out and they're regular. You're gonna make sure there's a P wave present for every QRS. Make sure it's upright, and then it's normal. And so that's going to tell you that this is a sinus rhythm if the P wave is present and upright for every QRS. You're going to measure the PR interval to make sure there's not a first-degree AV block. If the PR interval is greater than 0.20 seconds, there is a first-degree AV block. Now, you cannot have a first-degree AV block that it is not a rhythm in and of itself. You can only have a first-degree AV block with a rhythm. So in other words, it would be sinus bradycardia with a first-degree AV block, sinus rhythm with a first-degree AV block. First-degree AV block is not a standalone rhythm, okay? Next, you're gonna measure the QRS complex to make sure there's not a bundle branch block. QRS wider than 0.12 seconds is some sort of bundle branch block. We're going to look at the ST segment, make sure it falls on the isoelectric line, there's no elevation or depression. We're going to look at the T wave, make sure it's upright. We're going to measure the QT interval, and then finally we're going to interpret the strip. I hope this helps. Go Vols.